This is the case of core triatriatum sinister. Here what you can see, right atrium, try to focus, this right atrium, this is right ventricle severely dilated, this is left ventricle, and left atrium has been divided by a septum in proximal left atrial chamber and distal left atrial chamber. This is proximal chamber and this is distal chamber. Proximal chamber receives pulmonary vein and distal chamber gives rise to left atrial appendage, and there must be connection between these two, proximal and distal chamber, so that blood comes into proximal chamber, has to go into distal left atrial chamber and through mitral valve into left ventricle and then to aorta. So this is the case of core triatriatum sinister. Congenital abnormality you see in this case, the finding is this: septum is quite large and very small perforation is present between these two chambers, proximal and distal chamber, and that is obstructing the flow. And because of obstruction, proximal left atrial chamber has got obstruction, that is reflected in pulmonary vein, then pulmonary artery, then right ventricle, then right atrium. So like mitral stenosis, what you see, left atrium enlarged, right ventricle, right atrium enlarged, pulmonary artery hypertension, pulmonary venous hypertension. So similarly in this case, there is obstruction between proximal and distal chamber of left atrium. So little bit perforation is in the septum. So there is very much obstructed flow is here. We will see the obstructed flow in the next slides. That has caused develop pulmonary venous hypertension, pulmonary arterial hypertension, and right atrium, right ventricular hypertension, right ventricular systolic pressure is severely raised in this case. Now the next image, you see this is the part where the perforation in the septum, that is the part where the communication is established between proximal and distal LA chamber. This is septum, here the perforation you see. Here it is, perforation is here. A very much obstructed flow, you see that highly turbulent flow is here. That is why this has caused, you see, this is the part where the perforation is there. Here the perforation is between, perforation is the communication between proximal and distal LA chamber, and that is very much obstructed flow. You see the very much obstructed flow. That is why pulmonary venous, pulmonary arterial hypertension, and right atrium, right ventricle severe enlargement has happened in this case. Again see the same thing. You clearly see this is the proximal LA chamber and this is distal LA chamber. Just nomenclature. This is proximal LA and this is distal LA. This is left ventricle. This is mitral valve. So very narrow communication between proximal and distal chamber giving obstructed flow. That is why the flow is very much obstructed. Pressure is, high pressure is built in the proximal chamber, that is reflected upon pulmonary venous system, pulmonary arterial system, and right atrium, right ventricle. You see the right ventricle is severely dilated. You can easily see the size of right ventricle compared to left ventricle. Though the image is little bit shortened in this image, apical fourth chamber view, this is mainly right ventricle. Right ventricle comes in better in this view. That is the point to know in this image. Again you see the very much obstructed flow. You say the left ventricle is D-shaped, and the size, you can also see the how much size is there. You can easily see This is size of right ventricle, 33 millimeter, and size of left ventricle is only 13 millimeter, even more than 2 times, almost more than 2 times you say. So LV chamber is D-shaped, indicating severely raised right ventricular systolic pressure. Because of severely raised pulmonary artery pressure, severely raised pulmonary venous pressure, and severely raised pressure in proximal left atrial chamber. So left ventricular chamber is D-shaped, indicating raised right ventricular systole. This is TRZ. You see the TRZ, moderate TRZ, and severely raised. You see the pulmonary registration jet. This flow above the baseline is the PRZ, and below the baseline is flow across pulmonary valve, forward flow across pulmonary valve. So this is the case of core triatriatum sinister. If right atrium is divided into 2 parts by any septum, then that will be core triatriatum dexter. Left atrium sinister, right atrium dexter. This is the case of core triatriatum sinister, the congenital abnormality within left atrium, that is septum within left atrium, dividing left atrium into 2 parts. Proximal part receiving pulmonary vein, and distal part has left atrial appendage attached to it. You see the this proximal part is dilated compared to distal part. This is proximal part, because in the flow dynamics this part receives blood first, then this blood goes into this part. So this is proximal part, and this is distal part. So this is proximal chamber, this is distal chamber of left atrium. Thank you.